Hey everybody, welcome back to the shop. Getting ready to start on our next job here. So we got this piece of heavy wall tubing that we have to machine for a local paper company. I've been getting the American Pacemaker kind of cleaned up and just kind of getting things sorted out. I wanted to clean the lead screw as well. That was something that I never did in the beginning when we first got the machine in and got it set up. I wanted to kind of wire brush and clean the main lead screw, get all that rust off of it. So I did that this morning, got it clean. And anyway, getting it kind of set up. I still got some indicating and stuff to do, but I wanted to go ahead and grab the camera, show you where we're at, show you what we got to do, and yeah, let's just jump right into it. All right, so what we have is a piece of DOM heavy wall tubing. This is a 2 1/4 by 3 1/4 piece of tubing. It is 76 3/8 of an inch long. We have 1/8 of an inch that we need to face the end, so they did a good job of cutting it right where I like it, about 1/8 of an inch. So we do need to face the end. It does have to be turned from one end to the other. We have a pretty tight tolerance. I shouldn't say a tolerance. We have a size that we need to hit on that. And he says, you know, if we go a couple thou under that, that's not going to hurt anything, but it can't be oversized. So we do have a target dimension to hit on that because there's other pieces that actually slide on here and get locked in place. So we got to make sure we have that OD consistent, straight, and on size. The ends will be counterbored for a bearing. And the OD of the end right here is actually going to be turned and threaded for a big bearing nut. I'll show you those. I got those over on the bench. So we'll focus on getting at least half of it turned. I'm not going to be focused on turning it from one end to the other. We have a little bit of chattering that we may have to deal with on this. So what I'm thinking about doing is go ahead and get this end set up. And we're going to be machining a spot down here. Once we have the tubing run true, we'll just come down here with our tool, machine us an undercut so that we have a true spot on there, get our steady rest set to that, and then that way it's supported in the center. We don't have to worry about any kind of vibration and chattering. I'll also turn it down here so that our steady rest fits on in end, so that once this is flipped 180 degrees around, you have a true surface that is machined true with what you already machined down here. All right, so we'll get into more of that later on. Let me show you the print. They provided a drawing here for me to go over. This is what it's called, a female knife shaft tube. It has to do with cutting paper. All right, so 76 1/4 long. We have an OD of 3.148 inches. So that's a tight fit that we're gonna have to make sure we land on. We don't want it oversized, that's the main thing. We have the dimensions for the thread that goes on the end, the counterbore. So these are the bearings that get pressed into the end of the tube. And then this is your lock nut that's going to screw onto the tube there as well. They've actually got some dimensions on there, but I'm going to verify that. 3.137, 12 threads per inch. And they just want it 1 inch threaded onto the tube. So that's what's going to go on there and lock all of their cartridges in place once they slide them on there. So same thing for this other end there. All right, so I think that kind of covers what we got to do. We'll go ahead and start getting this thing trued up and go ahead and start making some chips with it. First thing we need to do is just go ahead and get this end trued up. I am way off center. I did not do my job. Huh. That's funny. I'm gonna bring this, I got you on the steady rest. I'm gonna bring this up just to catch it in case it tries to slide out of there, because I got that bell center in there. Still got about 150. There it is. It just slid out right there. Not what I was supposed to be doing. Put the center back in the end there on this side. Yeah, we usually have that much closer than that. This time I wasn't really paying attention. I just kind of opened it up and put it in there, and then grabbed the camera and started the job. That looks good. And a couple thousandths. Let's go ahead and check all of our jaws, make sure they're all tight. Yeah, it's well within a couple thousandths right there. All right. All right, let's get her fired up. See how it's gonna run. A little out of roundness on this side. It's typical for the IDs of tubes not to run perfectly true with the OD, but we've got plenty of material. We've basically got 100 thousandths to take off that, so we've got enough room there to not worry about this little bit of run out. First thing we're gonna do, we're gonna skin this down just enough to true it up so we can set our steady rest. That way we can go ahead and face it, and I'm gonna go ahead and focus on getting the counterbore completed and turn on this end and threaded for the bearing nut. And once we get those features finished, we'll go ahead and move on to the last stage, which is turning this end down. We'll just turn it back about 6 inches. That'll give us room. We can bring our steady rest right here and get all these end features machined. So we'll just get it cleaned up. Let's see how much it's going to take to clean it round. Still seeing a spot in there. Yep, it's got a little bit more there. I think that's going to be good right there. All right, we'll get our steady rest set now. This will be our first time using this steady rest for a job. I haven't tested it yet, but everything seems to be working good. All the rollers are working. I hope we don't have any surprises with it as we're trying to get a job completed. All right, we'll go ahead and let me just slow this down a little bit. We don't need to run it that fast to set them. All right, we just want to bring it up until it just touches. And on the American Pacemaker steady rest, what I always like to do is kind of keep you got the bolt that goes through there with a nut on this side that tightens this arm. I like to kind of keep it snug so that it's nice and square. Bring it up till it touches, just like that. Don't force it. I just make sure any of the slack is out of the screw. Tighten that, and we'll go around the back side. We're not going to reach over the machine to do that. That feels good. Lock this side. I'll go ahead, since I'm on this side, bring this one down. Same thing, bring it on down till it touches. All right, and then all I do is just make sure that the nut is just kind of finger tight on this, because you often have to slightly adjust that as you're doing some work. So keep this one unlocked but snug, just so you can adjust it if you need. Back off on the tailstock. That sounds like it's running really nice. Making me a shield for the steady rest here. Let's see if I got it. Yeah, I think that'll line up. There's grease zerks on those things where you can pump grease or oil in the bearings. That might, yeah, there we go. There we go. That'll hold it in place right there. That'll help keep chips from getting in there in the rollers. All right, first thing we'll do is just get this end faced off. We'll get it faced, and then we're gonna work on our counterbore for the bearing. Just wanna clean it up. All right, I'm gonna get a boring bar set up so we can get in there and get that counterbore finished now. Okay, we've got a nice Walter boring bar set up in there, 1.25" diameter, CNMG 400 insert. This is the type of bearing that's going in the end, a cartridge bearing. On the print, they've got the counterbore listed at 2" 440 thou. So I've got my mic just so we can verify this right here. And if I mic it, we're getting 2" 441. So that'll give it about 1 thou press fitted. So we'll just shoot for that target. We're gonna go 7/8 deep, and I don't have my scale, but that'll give a little clearance on this back face right there. So we'll go ahead and get it touched off and stepped off our 7/8 depth. All right, touch that face there. We're running 330 RPM on the lathe. That's just a nice smooth gear to run in. It's less noisy than some of the others. All right, there's our touch off. I got a dial indicator we'll use to set our depth. Got this mag back indicator with a tip extension on there to reach over the way wiper. Set a 0. Let's see if we go 875. Tool's clearing. 8. We'll go 870. It's just clearance back there, so we'll go an extra 5/10 thou just to clean that back face up once we're through with the boring. All right, I'm going to set me a 0 over here at the 3 o'clock position. It just gives me a 50 thousandths to watch this dial come up to our 0. All right, there's our stop. Go ahead and make a pass through here, get it cleaned up. I want to go ahead and get a measurement and see where we're at. Got to be careful not to overshoot our bore size on this. Just use some calipers to see where we're at right now. It's around 2.330. It's about 110 thousandths to come out. And we'll go ahead and slow our feed rate down, start making our finished passes. $2.380, that's where we're at. That last pass was, I dialed in 20. 405, 35 thousandths still to go. So I'm gonna take another 20 thou pass. What you saw me doing with the carriage hand wheel, moving that back and forth, I've got a dial indicator on this cross slide. It's a lot easier to look at this dial indicator and rely on that versus just the dial on the cross slide there. But as you kind of move it a little bit, shake it back and forth, you'll see it move just a little bit, and that can vary a thousandths. So I like to kind of just shake it a little bit, let it settle where it's going to cut, and then make the cut. All right, 425, 15 thousandths away from it. We're just continuing to sneak up on it. I want to make sure that the lathe is reacting good. Yep, see, I have to be careful because it's trying to cut like a thou over each time of what I'm dialing in. But we're still there. A couple little light cuts so I can sneak up on that size. I'm gonna go in there 5 thousandths, face that back. There's the Kaiser kicking on. That looks good. Looks like, how many tenths under did I hit it? 2 tenths. All right, so we're at 2.439 and 8 tenths. So I think that's pretty good. I can go in there with my flap if I need to and hit it just to hit the high spots off. But that bore, that's finished there. I'm going in there to chamfer those 2 edges. This is my tool holder that's got an ER40 collet in there. Got a 1-inch collet holding a 1-inch boring bar with a tool bit for chamfering. And we are running reverse, just easier to see it on that back side right there. Still got to kind of look up and over this, all while trying to avoid the handle sticking out of the hand wheel over here. Let's see if I can find a little bit of cutting oil to make that hopefully just a little bit nicer. A little bit right on that edge, on the tip of the tool. All right, got that one. Now I need to reach in there and do the other one. You probably won't be able to see that other edge, but I'm just gonna roll with it, get this done. That chip is still hanging on there. And my light just went dead. Okay. I think the battery's about dead. I'm just breaking that sharp edge in there. Like I always say, deburr all your edges. Don't leave any sharp edges on there for somebody to slice their finger open on. That's good. All right. That counterbore is finished up now. Okay, the next feature we're going to do is go ahead and turn and thread it for the bearing lock nut. This is for an AN16. So the tube is going to be turned to 80 millimeters, and that's basically what that AN16 nut, only it's 12 threads per inch. And the reason we went that route is because whenever they asked me about doing this job, there was originally going to be a metric nut. I told them this lathe will not cut metric threads. We can only do standard. So they found the right nut, 80 millimeter by 12 threads per inch. And I went ahead and verified the dimensions. They have got the diameter of 3.137, which is a few thou under that. The journal itself is going to be slightly under 80 millimeters, and the threads needs to be slightly underneath that. So I guess they figured out the diameter. Maybe they've got one that they're copying, so we're just going to make it 3-inch 137. Go ahead and mic it and see where we're at. We don't have too far to come down. 228, 3-inch 228. All right, so let's a little under 100 thousandths. All right, let's get the turning then. I'm gonna kick my feed rate back up, 10 thousandths. I've already got my dial indicator set to 1 inch shoulder length. You can see our cardboard chip guard is doing a good job there. Couple of finished passes and we'll have this on size. I just split it in half. We had about 40 to come off. So this is 20. I'll mic it. We'll make one more cut. Our finished pass. Next to 5 thou to clean that face up. All right, we're looking for 3-inch, 137. All right, we got 3-inch, 136 and 6/10. So we're 4/10 under what I was shooting for. Nothing wrong with that whatsoever. Got to put some chamfers on here. Need to chamfer this side really nicely. And then we'll go ahead and get started on threading. This would be our chamfer here. I got my threading tool in here, but we have a round nose insert that's 1/8 wide. I want to cut a thread relief there. That's the way that I like to do my threads. I usually do it for all the parts that I can. It puts a nice round corner in there, makes it look good, and it gives me a thread relief whenever I'm threading it. So here we go. Just going to be evened up with that shoulder that we cut. Let me get the tool touched off here and set a 0 on my cross slide. All right, there's our touch off. All right, there's our full depth. Now I'm going to widen that out just a little bit, blend that corner together. It would sure be nice if those chips weren't there so I could see it. Gotta go back in there again. There we go. All right. So I'll just swap that tool out for a threading insert. All right, we've got our threading insert installed. I'm going to go ahead and blue this with a blue Sharpie so that it's easier for all of us to see as we're threading it. All right, we need to get our tool touched off. I've already got the lathe set to cut 12 threads per inch. I'm going to use the compound here to come in here and touch our tool, and we'll set that to 0. I use compound in feed. A little bit too hard of a touch right there. I wasn't quite ready for it. Let's try that again. There we go, there's a touch. Let me set this to 0, and we'll make a scratch pass and verify our thread pitch. Go in a couple thou on that. Now I've only threaded on this lathe one other job, and it worked fine, but I am a little bit nervous because I haven't really proven it, but hopefully everything's going to work pretty well. So let's go for it. Let's give it a shot. Go into my 0 right there and stop. All right, let's get our screw pitch gauge. Got it set to 12, the 12 leaf. All right, and it looks good. We are cutting 12 threads per inch. Let's make a couple passes with the tool. I'll see if I can give you a video of, you know, like operating the controls over here. I did speed it up. That's 174 RPM. It's kind of hard to see the tool and reach over here and grab the lever for the half nuts. Take another cut. Another reason why I like having that undercut there. I know that it's not only a visual reference for me, it's audible too. I can hear whenever that tool stops cutting, and I know at the least I need to retract the tool out of the cut. All right, we'll try a couple passes like that there. I have a 0 here to reference, I have a 0 here to reference, and then we're using this for our end feed there. Go another 20 on this. Just want to line up one of these dashes. I have to bend over here and look. Another 0 there. See, when I'm standing right here, I have to look to the side of the tool because I can't see the tool over the tool holder itself. And then the lever's kind of like way over here. I'll line up this 0, and then that one lines up on 0 there as well. All right, so that's the movement. I want to go ahead and start hand fitting this bearing nut. It's not going to be exactly the full depth for 12 threads per inch because we're a little bit undersized on our major OD. So I'm just gonna thread it until this guy starts screwing on there. Not quite yet. It's getting close though. Thought I brought a file over here. I did. Getting close. Take 5/1000ths per pass now. Got some chips on it. Still not there. Close. Just taking 5/1000ths a pass on this compound here. That's that last thread where it's trying to break off. I'll have to file that. So it's fitting. We got it screwing on there. The way this thing is made with that rubber plastic material, that's so like a thread lock, so I won't be able to screw it all the way on there. It's a very, very close fit. I better do a spring pass just because of how close that. Right now we got it at a machinist fit. There's just literally no slack in that thread whatsoever. Let's try a spring pass and see if it'll just take a little more out. Using some cutting oil. Took a little bit. Find my file, go ahead and get that burr off of there. I'm happy with that. We got a successful thread. You got a really good fit on it. Just need a little bit more polishing just to kind of soften everything up, make sure there's no sharp edges or burrs or anything. I usually polish them up once I do the threads like that, hit it with a little bit of emery and some Scotch-Brite, and that just makes all of those sharp edges nice and soft. That is finished up, the thread anyway. Well, it's looking really good. I'm happy with it. Our threads and our counterbore look good. The machine is working really nicely, our threading. The second time that I thread a job over here, I feel a lot better about, since I took the time and cleaned that lead screw there. There was a lot of, especially down here on this end where it's not used a lot, there was a lot of built up just grease, grime, and gunk up inside those threads. And I didn't want those half nuts to be engaged in all that stuff. So wire brushed the thread real good, polished it, got it nicely oiled, and it seems to be working really good. I'm gonna go ahead and knock off. It's about 5:15. I got some other stuff to do, and I'm gonna get back on this. In the morning, I've got some CAD and CAM training with Kevin over at Mechanical Advantage. We got a couple hour session going into some parts that I've got to design. And so I'm gonna do the training in the morning, and after that, I'm gonna get back out here on this and get this going. I've got all week to work on this, so I'm not rushing it. I just wanted to start. Today's Monday, and I wanted to go ahead and and start working on it each day, and hopefully in a couple of days we'll have this finished up and they can come and pick it up. Next phase, we need to go ahead and get the OD turned. We got about 100 thousandths to take off that OD, so we'll take it down over halfway, maybe about 2/3. What I'd like to do first is we'll put our live center in there. We'll move the steady rest, and we'll get it down here out of the way. And I'd like to come down here, maybe turn a spot, just do a little undercut, true it, so that we can set our steady rest there. What I'm gonna do is I'm gonna try a cut. I'll probably go ahead and make a cut and see how it's reacting. And if we need to, I'll stop it and we'll put the steady rest there to support it in case we're getting any kind of chatter or vibration in the part. So that's the next phase of the machining project.